Myself Ashwin, and BISP Solutions is a tech company provide technological solutions across the world. Now this is our another session in the bootcamp. In this bootcamp we are showing you how to compare the regional sales. Now you might be thinking that why this NetSuite icon is here when we are talking about DNN, right? Deep neural network. The reason is that we are working on NetSuite data, right? So that is why I am showing you here the NetSuite icon. We are working on deep neural network, but how it will help in NetSuite data, in ERP data. That is why, because our main target is to discuss, is to study how this deep neural network helps in business. After all, business should get benefited with this deep neural network, right? We are not here to just understand the process of deep neural network. We are going to discuss exactly how it helps in increasing the sales, how it helps in the prediction, how to predict, right? How we are going to predict that what will be the sale. So for this purpose, what deep neural network is doing, we take the help of deep neural network and we provide the data, historical data. Now in that historical data, what we do, we feed all the regional data. Our agenda today is regional sales comparison. A company is distributing and selling the data, selling the product, sorry, not data, product, selling its product like cold drink or anything. Now the company wants to see that exactly how much sale is going on in every quarter in particular region. Suppose you can see here in the quarter 1, this is the sales scenario. In quarter 2, let me make it a little big. In quarter 1, the sales scenario in east, west, north and south, right? In quarter 2, what was the sales scenario in east, west, north, south? In quarter 3, what was the sales scenario in east, west, north, south? And in last quarter, what was the sales scenario? Now for us, we can calculate it, but we take help of deep neural network. What deep neural network does, it will show you exactly what will be the sales scenario in future, upcoming future, right? So that is what we are going to discuss in this session. Regional sale comparison refers to the analysis and comparison of sales performance across different regions or territories. Okay, this analysis helps businesses understand how sales are performing in various areas, right? Identify strengths and weaknesses and make strategies decision to improve overall sales. For example, if the businessman has given this type of data, normally there are so many criterias, right, on the basis of which, for example, if I give you some simple example, in one city the temperature is very high in summer season, right? And summer season, when temperature is very high and you are having the plant of cold drink manufacturing there's in that particular state or region, but still the sale is not high. Why? The reason is that there might be one reason that there are no colleges, so no youth, and those who are seniors, they know very well that it is better for health not to drink cold drink. So that is why, that is the one reason that the sale is going down. Second reason is that in that area, suppose the lemon and other herbs are available at very cheap cost, so people used to make other substitute at home also. That is another reason. So these are the reasons, these are some factors that impacts your sales, right? I have given you only one example. Again, I am iterating you. In a particular city, for example, in summer season, the temperature is very high, but still the sale is low. And at the same time, in other city, temperature is not that much high, but sale is growing very high. Now there might be, after analyzing that, the company found in this particular area where the summer season temperature is high but sale is down. The reason is that the lemon and other herbs that reduces heat, they are available at cheap cost, and there is no college there, so no youth. And those who are seniors, they already know that better make substitute instead of consuming the cold drink, company cold drink. So that's the one reason. And here in other cities, suppose the temperature is not that much high, but still the sale is high. The reason is not the summer season. The reason is that there are so many colleges, so many youth, and the age of 25, the person never know what is good and what is bad. So the student consumes cold drink. So that's the reason that the sale is going high, right? So these are some factors. And if a person analyze these factors, it takes a little time to make the future strategy. So it is better to use DNN techniques. Why these machine learning and deep learning techniques are invented? The reason is that to take quick decisions. So what we do, deep learning is also capable of thinking like this only, as what we have thought 10 to 15 seconds ago, right? So deep learning or DNN is also as capable as human to predict, right? It is 97% accurate. So what we do, we insert all the data into the machine and then predict the future strategy, or we can say take the output of this DNN technique, and then we think on it that what should be done next, right? Okay, just give me a second. Okay, yeah, okay, now let's do some practical. Now see here, I am going to now again create a new IPython interactive Python notebook, correct? Here I have opened IPNB is the extension, means interactive Python notebook. Okay, now we will start from here. Now see here, if I show you first, this is the Excel sheet. Now see, region, sales, product, look at this, product, then you will see quarter, then the year, then the gross margin, then sales percentage, gross income, rating average, median profit areas, right? So this is the data that I have downloaded from NetSuite. Okay, now I have downloaded from my ERP. This is the sales data. We prepare a report in such a way that all these things are downloaded in the report and some fields are missing. So in that case, we create a saved search in such a way that we put some formulas to calculate all these things, and then we download this CSV. That's the process. Now let's start with the DNN, right? Okay, now first of all, so what we do, first of all, to work on this, first of all we have downloaded the CSV sheet, right? Now after downloading CSV sheet, we have to keep it somewhere in a staging area that is called the folder area. Since it's a logical data, so the staging area is nothing, just a folder, right? Now here you see, we have to first when we are going to perform on the data, we have to first import all the necessary libraries. Okay, next what we need to do here, just a second. Yes. Now okay, now here you see our next step is to read the CSV. So what I have done, I have just shown you this CSV, right? Now see here, this is our data, regional sales, product type, quarter, and this everything. Now you can see total 5000 rows are there. Okay, so now 5000 rows. Now you will see here encode categorical variable. Now see, there are categorical variables also. Category means data is divided into different categories. When there is a categorical data, you have to use this DNN, deep neural network, and here you will see we have to use the label encoders where the columns are categorical. For example, region, it is divided into categories. Product type, category. Quarter, it's a category. That means different categories. Quarter 1, quarter 2, quarter 3, or we can say region 1, region 2, region 3, north, east, west, south, right? So we have done this. Now what we are going to do here, future features and target. Now see here, now see here, features and target. Features means, see, in a data, in our last sessions we have been talking about independent variables and dependent variables. Independent means those which are already available. Dependent means on the basis of independent variables we extract the data for the dependent variable. Okay, so now here also features and target means same. Region, product type, quarter, year, gross margin, sales percentage, rating, average, everything, these comes in the feature. These are the features of the data. Target means sales. This is what we are going to predict, correct? Okay, now what we are going to do here, now see, let me do this first, otherwise it will throw an error here. Hashtag means comment. Okay, now see here what we have done. X equal to df features and y equal to df target, and it converts the data in array between -1 to 1. Now this data is normalized. Okay, now let's do this. Okay, now come here. Actually here we are going to normalize, right? Scalar. Now this data is normalized. X, let me do this here. Now this data is normalized. So if I put it X like this, and if I put it Y like this, now see here, it converts the data, it transforms the data, right? So what it is doing, it is changing the data, and now the data is between -1 to 1, right? You can see the Y also. Okay, after that we are going to do train test split, right? So train test split means here you can see there is a function train test split. Now here train test split means 80% data we have to split into 80% data into training purpose and 20% data into testing purpose, right? That means 80% data it will analyze 80% data, and it will create a strategy in the back end, and remaining 20% data it will check that data. 20% data it will apply that 20% data on that strategy, and then strategy will give you the output. So it will match that output. If it is matched, that means the training is successful, right? So let's see this. X underscore train dot shape. Let me do this like this also. X underscore test dot shape. This 8 means it's a number of columns, y underscore train dot shape underscore test. Okay, now this is how it is done. Okay, now let's see what happens here. Now we have to convert the data into tensor, because we all know that we have to convert the data, then only it will work. It works in every level, right? We have to convert the data into the tensor. Now if I show you x underscore train, look at this, right? We have already learned about the tensors in our one of our bootcamp session. I recommend you to watch that video. In that everything is explained in depth, right? So look at this. Now here you can see number of column in X, converting the data in neurals. Now see here what happens. We are giving the data, complete data, to this sales model. We have created one sales model, right? Define the model. Okay, just a second. Oh, this hashtag is remaining. Okay. Here nn.module is inherited. Now see what happens here. Sales module, define the module, that is nn.module. We are inheriting it, right? After that sequential data is inserted here, and after that you will see this linear data, sequential data is in this 64 neurals are created, and with the help of ReLU function, that is the activation function, right? After applying this ReLU function, again the data is converted into 32 neurals. Again ReLU function is activated, and then this linear only you can see here only one, right? So either yes or no, right? Whatever the value, it is not about yes or no, it will generate one value, right? I will show you later on. Now let's come here. Now see what I'm going to show you. Model equal to sales model, criteria NNMSE loss. Now see, there is a difference in actual and predicted values, and that difference is calculated with mean square loss, mean square error loss, right? Mean square error loss technique. And you can see here optimization technique is used to reduce the loss, right? So that is what we are doing, all these stuffs, right? So optimization is required to reduce the loss. And now what we are going to do, our main target, which is very essential in every session, that is epochs. Now epochs is the repetition. We are now going to train the model, right? Train the model. So epochs losses array is created, but right now nothing is there, it's a blank array. And then you will see here epochs in range. Now see what happens here. Each time the loop starts, then the optimizer should start from beginning. Why this is written here optimizer dot zero gradient? That means each time the loop starts, then the optimizer is should start from beginning, because optimization technique is used to reduce the loss, right? So optimizer should start from beginning. Then loss equal to criteria output y train. We will compare the difference in the value. Whatever the value is the output. Look at this output value and the y train value. Y train means that dependent variable training value, right? So we will compare that here. We will compare the difference in the value. After that loss dot backward, again the process will go in the backward process, and that is called backward propagation, right? So again the process will go in the backward process, and that is called back propagation. Here it is written back, right? Now, and with the help of optimizer we will change the parameter in the model. Okay, so this is called with the help of optimizer. Okay, we will change the parameter of the model. Now losses equal to append loss item, and this is all we have done. And now the epoch started running. Now you can see here the loss is decreasing. On every epochs you will see the loss is decreasing. Initially it was 60265, then it becomes 2737, then it becomes 24, and at the end 0.2244, right? So that is called the loss is decreasing. Now see here evaluation. Now we are going to evaluate our data, our model. So model.eval equal to with torch no grid. We are not using, again now this time we are not using back propagation, right? So that's why no grid. After that, in this we keep the predicted values. Okay, we are doing the same thing, but here this time we are not using any back propagation method, and then in this we keep the predicted values. Okay, and then test loss equal to criteria. This evaluated the difference between the prediction and predicted and actual, right? So here we comes evaluated the difference between the predicted and the actual. Okay, so this is how we do. And then look at this, test MSE loss is 0.25, it is very low. Okay, now after that you will see here, and now we are changing the data into normal pattern with inverse transform. Now what is this inverse transform? We are going to convert this data into normal pattern, the value which was converted again reverse. That means we are again reversing that, right? So what we are going to do, that which was converted, it is now against reversed. Now we are okay. Now see here, here y test inverse equal to scalar y inverse transform and y test dot numpy. It is again converted into original format, right? Prediction inverse scalar underscore y inverse transform, right? So now our next step will be plot the data. Now plotting of data, it's a little complex. Now image, before going to image we will see first of this plot figure, that is the figure size, whatever the figure size, plot, and then let's make it a little small. Now see here, actual versus predicted sales, right? And we have plotted the value, right? Now what will happen here? Now you can see here what next. Here you will see training loss, right? Now we are going to plot the training loss. Okay, so you can see here, as the epochs runs, the loss becomes less. Okay, this is just for explanation, right? And now what we are going to do here, predict the new data. Now see, as I explained you, this was the historical data, right? And now we are going to give the new data. New data means label region we have given East, in the product type we have given electronics, in the quarter we have given Q2, in the year we have given 2024, gross margin equal to 0.35, and sales percentage, that is 0.22, and rating average, that is 4.5. that means everything, and median profit areas. Okay, that is 3900. Now see what will happen here. Now see, predicted sales for new data, that is 19,261. That means for this particular electronics item, in this particular quarter, for this particular region, and this particular in this particular region, and this particular year, then the gross margin with 0.35 percentage. So gross margin which is 0.35 and sales percentage equal to 0.22. So there is the output. Okay, now it has shown that 19,261 is the output. Okay, so again let's have a quick recap here. First of all, what we have received the data from the company. Now this company is having the data of all the 4 regions, of all the 4 quarters. That means whole year data is there that we are given, and for this we need to do the prediction that how much will be the profit for the next few months. And then what we need to do, first of all, you have to import all the libraries, correct? After that we have to extract the data, then we have to label encode, and then we have to convert it into fully numerical values, and with the in which our helper tools will be like standard scaler and fit transform, right? After that we have to pull the train test split function, right? We have to use the train test split function. Then what we have done, we have seen that it is distributed into 80-20, and then convert the tensors in convert the data into tensors. And as soon as you see here, now see, this is the sales model, right? Now in this sales model, what we have done, that I have already explained you, number of columns in X, converting the data into numerals. Okay, then what next? Model, sales model, MSE loss, right? There is a difference, always a difference between the actual and the predicted value, and the difference is calculated with the help of mean square error loss. Okay, then our traditional loop, that training loop, that is epochs 200 and this 200. I have commented all these things. Each time the loop starts, then the optimizer should not start from beginning. We will compare the difference in the value, all these things that we have done, and our epoch started successfully. After that we have to evaluate our data. So evaluation of our data, that is 0.2501, that means 0.2501. okay, then inverse transform for plotting. We have to transform again into our we have to transform the data again. Let's look at this. Now we are changing the data into normal pattern with inverse transform, right? That means all the data which is converted, all the alphabetic data which is converted for this machine language into temporary numerical part, they will again be restored and provided the data. After that, you will see here plotting the data. Now we are going to plot the data, right? After that, you will see plotting actual versus predicted. It is overlapping each other, right? The blue lines are overlapped by the orange lines, right? So it is a little somewhere overlapping each other. After that, you will see plot training loss, how the loss is decreasing. If you want to see, then you have to plot the loss here, and then we have to apply on new data. Whatever the data you have, that you have to apply on new data, and then you will see you have to put all the data, and then you will see these are the items, that this particular item, right? This particular item, electronics, and the product type. This is the product type, this is the region, in this particular region east, and the quarter, that is Q2, that means April to June, right, which is the second quarter. Okay, so this is how it is done. So guys, this is another important subject, right? So watch this video twice, thrice, and then only you will come to know the exact thing, because in first attempt it is it will become very complex. So that is why we have to practice it again and again. So I recommend you to watch this video again, and if you have any doubt, then reach out to me. Then you can put down your questions in the comment box. I will resolve them. Okay, so now today we are concluding here only, and in our next session we will discuss on some important topics, right? And till then, you practice this, do it 2-3 times, and watch the session recording again and again, right? And then in our next topic tomorrow, we will see something new. Okay, and those who are new to this channel, I recommend you to subscribe the channel. Okay guys, thanks for attending the bootcamp session. See you tomorrow. Thank you. Thank you.